Okay, so let's look at an example where we have to use this concept of using that table to figure out the t-score. A random sampling of 16 students was selected from the student body at a local college to determine the average amount of money that students carry with them. So immediately we know what the sample size is. If the sample mean X bar was equal to $28, so we know what X bar is, with a sample standard deviation of S equals 6, okay, so we know we have our sample standard deviation 6, then construct a 95% confidence interval for estimating the mean amount of money all students carry on them. And we're also going to interpret that. Okay, so the formula for a 95% confidence interval when dealing with the t-distribution, now we know we're dealing with the t-distribution because we don't have a population standard deviation, we have a sample standard deviation. The formula is X bar minus t subscript 97.5% times S divided by the square root of n to X plus t subscript 97.5% S divided by the square root of n. Now that 97.5%, where does it come from again? Well, that's the area to the left of the t-score when you're cutting off the middle 95% of all t-scores. So to figure out what X is, we know it's 28, S is 6, N is 16, but the thing that we don't know is the t-score, so we have to go to our chart. So if our sample size is 16, then degrees of freedom is 15. So we go to our table and we look up 15 and we look up the column 97.5%, and you should note on that column that the t-score in question is 2.13. Okay, so you look at the column 97.5%, you go down to 15 degrees of freedom, and it is 2.13. So you plug in those values into the formula. So you have 28 minus 2.13 times 6 divided by the square root of 16 to 28 plus 2.13 times 6 divided by the square root of 16. And we get 24.81 to 31.20. Now again, because it's money, we're going to round to 2 decimal places. The interpretation is we are 95% confident that the true population mean amount of money students carry with them is from $24.81 to $31.20. So again, even though we don't have the population standard deviation, the goal is still the same. The goal is to estimate the true population mean amount of money. The margin of error should be found in the same way. You're going to take the upper limit minus the lower limit divided by 2. Remember to wrap that numerator in parentheses. So 31.20 minus 24.81 divided by 2 gives you a margin of error of 3.20. So you could also express this confidence interval as 28 plus or minus 3.20. Okay, if we're going to do the same problem, but we're going to change our confidence level to 99%. So instead of using the 97.5% column, we're going to use the 99.5% column to figure out the t-score. So you're going to go to that chart again. You're going to go to 15 degrees of freedom, and this time you're going to go over to the column labeled T subscript 99.5%, and you'll get a t-score of 2.95. Using that t-score, plug it into the formula. So you're going to plug in 28 minus 2.95 times 6 divided by the square root of 16 to 28 plus 2.95 times 6 divided by the square root of 16. And I'll do it on the calculator with you. (28) minus 2.95 times 6 divided by the square root of 16. So 23.58 when dealing with money. And change the minus to a plus to get the upper limit of the confidence interval. And you've got 32.43. So 23.58 to 32.43. So if we were to interpret this, we say we are 99% confident that the true population mean amount of money students carry with them is from 23.58 to 32.43. What's the margin of error? We're going to take 32.43 minus 23.58 divided by 2, which is 4.43. So we could also state that our confidence interval is $28 plus or minus $4.43. So what we just did today was two types of confidence intervals. We learned how to do confidence intervals for estimating population means when we know the population standard deviation, and then again when we don't know the population standard deviation, and when we have the sample standard deviation instead. So using the sample standard deviation involves a little bit more work because you have to use your t-distribution and find the t-score from the chart. But other than that, it's a pretty similar concept and similar formula.